The probability of fair coin came up heads. Some people say 1/2, others say 1/3. Both are experts in probability. No terrifying equations here. Addition, division, and one computer experiment are all we need. The beauty in the fairy tale pricked her finger on a spindle, slept 100 years, and woke with a prince. Today's beauty faces a different situation. She lies on the lab bed of her own free will, no curse, and the morning greeting the experimenter offers is not a kiss, but a single question. The coin is perfectly fair. Heads and tails exactly 50-50, so surely the answer is obviously 1/2, right? Those who answer that way are called halfers. Yet to the very same question, there are thirders who calmly answer 1/3. This is no joke. Both sides are philosophers, mathematicians, statisticians. The problem debuted in a 2000 paper. 100 more followed, yet no winner emerged. In 2023, the major science channel Veritasium posted it as the most controversial problem, and rebuttal videos promptly lined up one after another. Using only addition and division, we'll walk both sides' logic, then run the beauty's week 10,000 times to see it with our own eyes. First, let's write down the rules exactly. Sunday night, the beauty hears all the rules, agrees, and falls asleep. Once she's asleep, the experimenter tosses a fair coin once. If heads, she is woken exactly once on Monday, questioned, and put back to sleep. If tails, she is woken on Monday and questioned, given a memory-erasing drug and put back to sleep, then woken again on Tuesday and asked the very same thing. On Wednesday, either way the experiment ends, and the beauty wakes with no question and goes home. Here's the key clause. The awakened beauty has no way of knowing what day it is, or which awakening this is. The drug erases only the memory of having been awake, so she remembers the rules perfectly. In other words, her mind upon waking is in exactly the same state every time. One detail that becomes a weapon later. The coin can be tossed after Monday's question ends without changing the experiment. It only decides whether to wake her Tuesday. Since words get confusing, let's draw the beauty's week on a single calendar page. There are only 3 places she can open her eyes. Heads Monday, tails Tuesday. And from the inside, the 3 rooms look perfectly identical. The beauty knows neither which world she's in nor which seat she occupies. All of this problem's poison flows from this single drop. Now let's open the courtroom. Sunday night, ask the beauty just before she falls asleep, and the answer is obviously 1/2. There's no room for dispute here. There's an iron law of probability. To change a belief, you need new information. So what exactly did the awakened beauty learn that's new? That I am awake right now? That's something Sunday's beauty was already certain of. Heads or tails, she is bound to wake at least once. Since nothing unexpected happened, there's nothing to update. The answer stays as it was Sunday night, 1/2. The one who formally defended this position was David Lewis, a giant of 20th century analytic philosophy. His 2001 rebuttal was among the last papers of his life. Clean, isn't it? But if it were this obvious, no quarter-century war could have broken out. Now the opposing counsel jabs at a strange spot from the very first word. The first argument appeals to the most primal instinct. Over many trials, how often does it happen? Repeat this experiment 100 weeks and about 50 are heads, 50 are tails. Heads weeks have 1 awakening, tails weeks have 2. So the awakenings are 50 on the head side, 100 on the tail side, 150 in all. Of those, the awakenings where the coin is heads number 50. 50 divided by 150, exactly 1/3. Answer 1/3 every time, and over the long run you're right exactly 1/3 of the time. A good probability should match the rate of being right. That's the starting point. Words won't settle it, so let's count directly. We'll simulate the beauty's week 10,000 times and keep 2 ledgers. 1 by week, 1 by awakening. Of 10,000 weeks, 5,015 heads and 4,985 tails. At 50.1 to 49.9, the coin is beyond doubt fair. But move to the ledger of awakenings, and the mornings total 14,985, of which the heads mornings number 5,015, 33.5%, almost exactly 1/3. Here's the most important observation. Both ledgers are correct. The two camps are simply counting the same world with different denominators. Tails weeks getting counted twice in the ledger. Haven't we seen this scene somewhere? It's a scale where whatever lingers longer gets caught more often. Beyond frequency, there's one more knockout blow. It's the symmetry argument of philosopher Adam Elga, who debuted this problem in 2000, done with balancing alone. First, Tails Monday and Tails Tuesday. There's no ground to give two seats perfectly indistinguishable to the beauty different probabilities, so the two must be equal. Second, Heads Monday and Tails Monday. Whisper to her that it's Monday and all that remains is a single coin. What's more, that coin may not even have been tossed yet. Since all three seats have equal probability and sum to 1, each seat is 1/3. Heads is only one of the three seats, so the probability of heads is 1/3 too. What about the iron law that no new information means no update? The thirder answers. There is new information, simply of a different kind. What the awakened beauty learned is not the world, but her own position within that world. Philosophers call this self-locating belief. Let's view it through conditional probability too. Let heads be H, tails be T, and being awakened question right now be A. Then Bayes' theorem reads like this. The priors are a common 50-50. The battlefield is the likelihood. The halfer reads A as wakes at least once, so both likelihoods are 1, and the answer is 1/2. The thirder reads A as awake on this particular day called today. The heads world is awake on only one of 2 days, the tails world on both days. Plug it in. 1/4 divided by 3/4, exactly 1/3. The denominator fight from the story shows up in the equation as a likelihood fight. When philosophy runs to parallel lines, we ask the market. Beliefs can be hidden, but the wallet is honest. Each time the experimenter offers a coupon that pays 1 coin if this coin is heads, how much would you pay? Believe it's 50-50 and you pay up to 0.5 coins. In a heads week you buy 1 coupon and receive 1 coin, so plus 0.5 coins. In a tails week you buy 2 coupons and receive nothing, so minus 1 coin. Since the two worlds are 50-50, the average per week is minus 1/4 coin. Even with a fair coin, buying at the 50-50 price bleeds you steadily dry. So what's the fair price that doesn't ruin you? Repeat the same arithmetic, and the one point where the weekly average hits 0 is 1 and only 1/1/3. Let's see it in simulation. On the left, buying about 15,000 coupons at the 50-50 price, the beauty ends at minus 2,477.5 coins. At the 1/3 price it's plus 20 coins, essentially break even. The better scale points to 1/3. Just when the match seems over, the halfer rises, pointing to the picture on the right. The settlement method is a con. The 2 coupons in a tails week aren't because belief is doubled. They're the same situation counted twice. Settle once per experiment and the fair price returns to 0.5 coins. What's more, give the beauty the freedom to skip the bet or to split the stake and the price shifts again. There's even a whole paper dug into just this point. So the wallet can't be the judge either. The bet's answer follows the settlement rule, and we set that rule. The question itself was unfinished. And yet, at the moment of decision, you ultimately have to pick a single number. So both camps push their answer to the end, and at that end each bit down on a painful bullet. The halfer's bullet. The Monday confession. Tell her it's Monday and heads Monday is 1/2, while tails Monday and Tuesday are 1/4 each. Erase the Tuesday cell and the Monday cells leave 1/2 against 1/4, so the probability of heads rises to 2/3. But that coin may not even have been tossed yet. She must say the probability that an untossed fair coin comes up heads is 2/3. Lewis accepted this consequence outright. The thirder's bullet. The foretold change of mind. On Sunday night the beauty says she'll answer 1/3 tomorrow morning, yet says it's 1/2 right now. Foreseeing your future belief perfectly, yet not following it now. This collides head-on with a standard rationality principle, the so-called reflection principle. There's even a third camp, the double halfers, who try to dodge both bullets. Waking 1/2. Hearing it's Monday still 1/2. But they have to tamper with the standard rule of probability updating. Let's push intuition to its limit. Nick Bostrom's extreme version. Change just one rule. If tails, wake her not twice but 1,000,000 times. By third or arithmetic there are 1,000,001 seats and heads is still just one. The probability of heads drops to 1 in 1,000,000. Barely awake and it's almost certainly tails. The halfer isn't comfortable either. Whether the awakenings are 1 to 2 or 1 to 1,000,000, she must hold to 50-50 without batting an eye. Intuition screams at both extremes. In the 2020 PhilPapers survey, of 429 respondents, 28% were thirders and 19% halfers. The majority, 53%, withheld judgment or said there's no right answer. Among the papers, thirders are the majority view, but there's no consensus. The bones were laid by Arnold Zuboff in the 1980s, the name given by Robert Stallnaker, and the debut bout was Elga versus Lewis. Are grown-ups taking a mere bedroom puzzle too seriously? Because peel back the shell and a much bigger question comes out. When an observer exists many times or as many, what may you infer from the fact that I am here right now? This question appears in far greater form outside the bed. First, cosmology. The physical constants look astonishingly fit for life to exist. A popular explanation. There are countless universes and we observe only where life is possible. Is the fact that I'm awake evidence for the many-observer hypothesis? Count like the thirder and it's the self-indication assumption. Count like the halfer and it's the self-sampling assumption. The beauty is a tabletop model of this cosmic question. Next, the doomsday argument. It's the notorious argument that estimates humanity's remaining lifespan from where I fall in the order of all humans ever born. Whether this stands or collapses hinges precisely on which way you count the beauty. What looked like an idle puzzle turned out to be an invoice for humanity's lifespan. Last, quantum mechanics. In the many worlds interpretation, every measurement realizes all outcomes on different branches. If everything happens, what does a 70% probability even mean? A leading answer reads this as self-locating uncertainty. On which branch is the me that is now me? A single coin in the bedroom casts its shadow all the way to the branches of the cosmos. Count by the coin's ledger and it's 1/2. The heads rate per experiment is 50-50, and this is a flawless fact. Of 10,000 weeks, heads were 50.1%. Count by the morning's ledger and it's 1/3. This too is a flawless fact. Of 14,985 mornings, heads were 33.5%, sharing one root with the inspection and friendship paradoxes. The fight surrounds a single word. Whether probability is a belief about the world, or a belief about my place in it right now. Even the bet couldn't be a judge before the settlement rule. The lesson to carry beyond the bet is just one. If your probability comes out different from someone else's before you fight, first ask, do we, in fact, share a denominator? In the forest of probability, even the way you count how many times you woke becomes philosophy. Tonight, may your sleep be free of any worry about the denominator. If you enjoyed the video, please support it with a subscribe and a like. See you in the next story.